All right, so for the next one, we've got e raised to the negative 3k plus 8 is 31. So I notice that my k is trapped up in my exponent. So I'm going to work to get to that k so I can solve for it. So I'm going to subtract 8 from both sides. So this gives me e to the negative 3k is 23. And now I'm kind of sort of stuck. So I'm going to take the natural log of both sides. And then that allows me, now that I'm in log world, to drop this exponent out front as a coefficient. So I've got negative 3k times the natural log of e is the natural log of 23. And if I remember, natural log of e is the same thing as 1. So I've got, now just to solve for k, I can just divide both sides by negative 3. So I have k equals the natural log of 23 over negative 3. And so that is my final answer. Okay, we have number 13 is 2 raised to the 6x plus 7 equals 3 to the x minus 9. So now I'm kind of stuck right off the bat. 2 and 3 are not the same base, and my variables are stuck up in the exponents, and there's really no easy way to rewrite 2 as a power of 3 or 3 as a power of 2. So I'm going to go ahead and dive into natural logs. So I'm going to take the natural log of both sides. And now I can drop this exponent out front as a coefficient. And I'm going to make sure and put those exponents in parentheses because they both, all the contents belong to the natural log of 2 and all the contents belong to the natural log of 3. So I'm trying to get x by itself. Remember, the natural log of 2 is a number and natural log of 3 is a number. So I'm going to distribute the natural log of 2 to both of these. So I've got 6x times the natural log of 2 plus 7 times the natural log of 2 equals x times the natural log of 3 minus 9 times the natural log of 3. Okay, so I've got 4 chunks. This chunk has an x, this doesn't. This chunk has an x, and this doesn't. So I'm going to subtract this one over to the right, and I'm going to subtract this one over to the left. So I've got minus 7 natural log of 2, minus 7 natural log of 2, minus x natural log of 3, minus x natural log of 3. So on the left, that gives me 6x natural log of 2 minus x natural log of 3 equals negative 9 natural log of 3 minus 7 natural log of 2. Okay? So from here, my x's are now on the same side. I'm going to factor out an x. So that leaves me with 6 natural log of 2 minus the natural log of 3 equals negative 9 natural log of 3 minus 7 natural log of 2. So all I've done is factor out that x. And now I'm going to divide both sides by what's left in parentheses. So I've got 6 natural log 2 minus natural log of 3. So that reduces on the left. And that gives me x equals this whole thing over here. Okay? So number 14. This time we're going to start in log world. Okay, so I've got the log, or the common log of x plus 9. This is in base 10. If your base isn't written and it says log, you're in base 10. Okay, So I'm also going to put a big fat star next to this one. I need to check my answers to make sure that my argument doesn't go negative or go to 0. I only want positive arguments. So I'm going to start by rewriting this as a, if it's joined by addition on the outside, it's joined by multiplication on the inside. So that x times 9 is kind of throwing my brain off. So I'm just going to rewrite that as log 9x. So now I'm in the same situation as I was a couple problems ago, where I've got the log that's the same on the left and the right. Now I got to concentrate on these. So I've got x plus 9 equals 9x. So I'm going to subtract x to both sides and divide both sides by 8. So I get 9/8 equals x. And now I need to check my answer. So my answer here is 9/8 plus 9 is positive. So I'm good. Okay, 9/8 is positive. So I'm good. And nothing affects the 9, so I'm good. So my answer is 9/8, and I checked my work. Okay, so now we've got power functions and polynomial functions, both or neither. So a power function, we're just going to go through and define what these are. So a power function is one term with a power on the variable. Okay, a polynomial function is multiple terms which could include one term. Okay, but the polynomial function has counting number exponents on the variables. Okay, it has counting number exponents on the variables. So an example of a power function would be x to the 7th. Okay, an example of a power function would be x to the 5th underneath a radical, because that's the same thing as x to the 5/2. Okay, so those are examples of power functions or polynomial functions. All right, so number, what are we on? 16. We have x to the 4th (2x minus 2 squared). So I want to know what the degree is, and I want to know what the leading coefficient is. So this is set up as a multiplication problem, so I need to count how many x's are being multiplied together. So there are 4 x's here, and there are 2 x's here being multiplied together, which gives me a final answer of 6 x's being multiplied together. So my degree is 6. My leading coefficient is going to be, this is a 1, and this is a 2 squared. So 1 times 2 squared is 4. Okay, so let's try another one. I've got 4 plus 4x to the 2nd. So first of all, it's not in descending order, so I'm going to fix that. This is an addition problem. So since this is an addition problem, I can just look at my lead term. So my degree is 2. and my lead coefficient is 4. Okay, I've got x to the 5th, 25 minus x squared, and 2x plus 1. So this is a multiplication problem, so I've got to count. So I've got 5 x's here. I've got 2 x's here, so that's 7. And I've got 1 x there, so that's 8. So my degree, if I multiplied this whole thing out, would be 8. And my lead coefficient, this is a 1, this is a -1, and this is a 2. So 1 times -1 is -1, times 2 is -2. Okay? All right, if we want to know x-intercepts and y-intercepts, write the problem down first. So I've got -2 times x plus 5 times x minus 2 times x plus 8. And I want to know what the x-intercepts are. So this is set up as a multiplication problem. It's already been factored. So my x-intercepts are going to be at -5, 0, 2, 0, and -8, 0. So if I put in a -5 here, -5 plus 5 is 0. So 0 times the rest of that is 0. Okay, if I put in a 2, 2 minus 2 is 0. If I put in a -8, -8 plus 8 is 0. Okay, my y-intercept is going to be a little bit more exciting. So my y-intercept, I'm going to put zeros in for my x's. For my x-intercepts, I want zeros for y's. For y-intercepts, I want zeros for x's. So that gives me a -2 times a 0 plus 5 times a 0 minus 2 times a 0 plus 8. So that gives me -2 times 5 times -2 times 8. So that gives me 4 times 5 is 20 times 8 is 160. So my y-intercept is 0, 160. Okay. And then we're going to stop this video a little bit earlier, and I'll finish the last video, which is all factoring.